Hey everybody, welcome back to another video. Today we're going to be going over concepts that we discussed in class. I hope this video can be used as a supplement to everything we've talked about in class. This shouldn't be your primary source of learning some of these concepts, but I really do hope it reinforces things that we've discussed in class. So just as an overview of today's video, we're going to be talking about Booleans and conditional statements. We'll go ahead and do some short examples, some code snippets, and we'll also be doing a little bit of review on previous concepts. As you know, if you haven't already figured it out by now, we are going to be building concepts on top of each other throughout the duration of the course. So I hope that the review and the supplemental video on Booleans and conditional statements is really helpful in your understanding of programming. So with that said, let's go ahead and get right into the video. Alright, welcome to the coding portion of this video. To begin, we're just going to be talking about some of our concepts really quick. So first off, what we have is a Boolean. So what exactly is a Boolean? Well, you can think of a Boolean kind of similar to an algebraic expression. So you have something like x plus y equals z. So you have some statement equal to some value. In previous examples, we've seen things like x equals to 23. We can do y equal to 14.3, right? And we know that this is an integer; it's a whole number. We know this is a floating point variable, decimal point. We've also covered strings, so we can say something like this. Booleans are going to be our fourth data type. They're going to be our fourth type of variable that we're going to be covering in Python. And we'll go ahead and just create a simple variable. We'll just call it raining. And whenever you're creating Boolean variables, they can only represent two different values. So when you have an integer, integers can be any whole number. It could be 23, it could be negative 23, it can be really any whole number. Same thing with a decimal point. It could be any decimal point. It could be 14.3, 14.347. It could be negative 14.347. It could really be anything. Same thing with a string. I can add numbers in this string. I can add random characters. I can add anything I want. As long as it's encompassed within the quotes, it's a string variable. But with a Boolean, I could only have two values. All right, so I can only have a true, I can only have a false. There is no maybes, there is no in between, there's no gray area with Booleans. It's just true or false. And the way we assign the value, so with an integer, the way we assign the value is just by explicitly saying, hey, x is going to be equal to 23. With a float, we explicitly can say, hey, x or y is going to be equal to this value. Same thing with a string. With a Boolean, the two values is just true. So you'll notice as when I type this in Visual Studio Code, it even highlights. And Visual Studio, that's Visual Studio telling us, hey, this is a key word in Python. This is important. This isn't just some random value. If I try to type this as a variable name, let's say I try to say true is equal to 23, I'm gonna get an error because Python's gonna be like, hey, this is an important keyword in Python. You can't use this as a variable name. So we'll go ahead and go back to our raining and actually change the name to is raining, right? Because that's something I would want to know. If I'm creating some weather application, I might have a Boolean variable that represents whether or not it's raining outside or it is not raining outside, right? So there's no in between. There is no, yeah, it's somewhat raining. It's either raining or not raining in this case. If I want it to be false, I'll go ahead and just type false. And I want to make sure I capitalize the first letter of either T or F. If I try to write it lowercase, but just like this, you'll notice it doesn't highlight because that's Python saying like, hey, this is just another word. It's not really important to me. I don't know what it is. I could create a variable called false, lowercase, and set that equal to the Boolean value of false. And this works fine because lowercase false is not an important keyword, but the capital F denotes that, hey, this is an important keyword in Python. This means we're creating a Boolean and assigning it the value of false. So I could say something like, in my example, is raining. I could create a conditional statement, and that brings us to our next point. So what is a conditional? Wow, I can't type. Conditional statement. So, and I'll go ahead and delete these examples because they're kind of silly. So a conditional statement, you've probably heard, a bunch of different examples of conditional statements throughout your life, and maybe you haven't even noticed it. Maybe you've heard things like, hey, you can go to the mall if you clean your room, or you can go outside if it's not raining, right? You've heard a bunch of these conditions, like you're allowed to do this if that, you can do this if that. And that's exactly what a conditional statement is. It's a statement that's conditioned on some statement. And in Python, we can write something like that using our example, like you can go outside if it's not raining. If I just type that in English, if it is not raining, then you can go outside, right? And then I'll even create a Boolean variable to represent whether or not I'm allowed to go outside. So go outside is going to be equal to false, right? So originally it's not raining and I'm not allowed to go outside. And here's my statement that I would normally just say in English. So if it is not raining, then you can go outside. Okay, so if it is not raining, okay, well I have this Boolean value is raining and saying false. So I can just replace my statement with this Boolean. I could say something like if is raining. So if is raining is true, or if is raining is false, then do something. So if is raining, and then in Python I'll add a colon, and then everything underneath, it has to be indented, but everything underneath this conditional statement, so underneath this if statement, is going to be the code that executes whenever this is true, only if it's true. So right now, if I run this program, if this were actual code, if I run this program, this statement would not happen because Python would check this variable. It would say is raining is false. Okay, I'm just going to ignore this because I only want this to happen if it's true. So I could change this to true. So if it's raining is true, right? So this is the same exact thing as saying this. So if is raining is equal to true, then you can go outside. Okay, well I have a variable go outside set equal to false, but it's raining. For some reason my parents want me to be able to go outside when it's raining. So I can just say, oh, okay, go outside is now going to be equal to true. Because it's raining, I can go outside now. And then I could do the same thing with, any variable. So let's say I have a variable and I'll call it age, right? I have a variable called age, set it equal to 14. Then I have another Boolean variable called birthday. And it's just going to represent whether or not it's my birthday or not. And I could say something like, if birthday is equal to true, so if it is my birthday, then I'm going to increase my age by 1, right? So now age is going to be 15. And we'll go ahead and print out our new age. So we can say something like, happy birthday. You are now age years old. Whoops. Just like that. Let me go ahead and add some spaces. I'll delete this one right here because I think Python's going to automatically add it. So if it's my birthday, go ahead and add true. My birthday passed. So now I can set birthday equal to false because it's no longer my birthday anymore, right? I have to wait another year for this to happen. And then if we print out age before, just to make sure, just to check to see if our value age is being updated, we can just write it before our statement. And if we run this, we're going to get age 14, happy birthday, you are now 15 years old, just like that. And then in this one right here, we can even print, you are allowed to go outside because it is raining. And if we run this, there it is, you are allowed to go outside because it is raining. And instead of saying if is raining is equal to true, it's a little bit redundant. This is kind of like saying if true is equal to true, right? Because is raining is set equal to the value true. So this is the same exact thing as saying if true is the same as true, then do this. So we don't need to do that. Instead, what we can do is we can just say if it is raining. So if it is raining, print you're allowed to go outside, set go outside equal to true. And then same thing with this. We don't need to be redundant. We don't need to compare true and true. We can just say if birthday. So if birthday is equal to true, then, say happy birthday, increase age, your birthday's now over. So we'll go ahead and set this variable equal to false. We could also use different operators to compare things. We don't have to just use these Boolean variables. So we can use comparative operators. So things like greater than will be this symbol right here, this little greater than. You've probably seen this in like math classes. We have greater than or equal to, and this is just going to compare whether or not something is greater than a value or equal to the value. And that's just going to look exactly like that. And then we'll have the same exact thing for less than and equal to. So instead of this symbol, it's just going to be that one and that one. And as you probably saw in this example right here where I wrote if true equal equal, those double equals represent comparing two values to see if they are the same. So it's not assigning a value, it's comparing a value or comparing two values. So if I say something like x is equal to 13, I'm saying, hey, take 13, set it equal to x. So whenever I print x, I'm printing out 13. But if I say x is equal to 13, then I'm saying, hey, is x the same as 13? Well, in this case, yes, it would be, because I assigned 13 right here. And now I'm just saying, hey, are 13 and 13 the same values? But if I said x is equal to 14, and then I compared the two values, so x is that the same as 13, this would be false, right? So if we printed this out, we can actually go ahead and do that. If we print it out, if my keyboard works. What's our time? 11 minutes, okay. If I just printed out what this value is, I'm gonna get false printed out because 14 is not equal to 13. And there we go. We get false printed out right here at the bottom. Now, if I set x equal to 13, so now I should get true because these two values are the same. If I went ahead and run this, I'll get true. And then let's say I want to represent if two values are not the same. I can do that too. So comparing if two values are not the same. We're just going to be using the exclamation point and equals. This exclamation point, you can think of it as not. So we would always say not equals when we read this. So now I can just print out, is x not equal to 13? Well, x is equal to 13, so this one is going to be false because they're the same and we're checking if they're different, which they're not, so this is false. And we should get false printed out right here. Now if we said, okay, and they don't have to just be numbers too, we can write hi right here and we can say, hey, is the variable x different than the number 13? Are they not equal to each other? And they aren't equal to each other. Hi and 13 are different values. So if we print this out, we're going to get true because they are different values. And we can even apply this same logic inside conditional statements. So we could say something like, if x is not equal to 13, print out x is not equal to 13. And then we can check if they are equal. So if I want it to be a part of the same branch, I'll say else if or elif. So else if x is equal to 13, print out x is equal to 13. And if I run this, I should get not equal. So I should get x is not equal to 13 because as of right now, they're different values. So if I went ahead and run this really quick, I'm going to get that print statement, right? So if we look at the code, x is high. We're comparing it to the value of 13. They're not the same. Python reads this line. It says, okay, this is true. They're not equal to each other. So let's print this out. And then it completely ignores everything underneath these branches because we've found our true value. We found what we want to run, what we want to happen in our program. Now, if I set these values equal to each other and run this one more time, I'm going to get x is equal to 13. So Python goes through our code. It says, okay, x is 13. Let's go ahead and print if they're different. They are not different. They are the same. So we're going to print out false. Then it reads this line and says, okay, if x is not equal to 13, well, we don't care about that because they're the same. So we're going to completely ignore this line of code right here, and let's check the next branch. Let's go on to the next check. And it'll say, okay, well, is x equal to 13? Are they the same values? This is the case, so we print out x is equal to 13. And we can add as many else if statements as we'd like. We can say, okay, I want to make sure, I want to have a check to see if they're equal to each other, if they're not equal to each other, or if x is greater than 78 for some reason. I want to, and then I'll write code right here. I want to check if x is less than 43 or 44 and x is greater than, x is greater than 23. So I can say right here, x is in between 23 and 43. And then right here, I'll print out x is greater than 78. So this is something new that you may not have seen before, but we can compare multiple statements. So we can say, okay, if x is less than 44 and it's greater than 23, then it must be in between. So let's print out, these two numbers or x is in between these two numbers. If we don't care about both of these conditions, right? So if we don't care about both of them being true, we only care about one of them being true. Instead of saying and, we can say or. So we can say, hey, if this is true or if this is true, go ahead and run this code. We don't need them both to be true. We just need one of them. But if we say and, we're telling Python, hey, only run this code if both of these statements are true. And yeah, that's pretty much it. That's about it for this overview on conditional statements and Booleans and applying some of this logic to create programs. I know this isn't the most applicable program, but again, I just want to generalize this concept and make it really easy to understand and grasp. I hope it was helpful. If it's still confusing, please do leave a comment or send me a message. And yeah, see you later.